Hey there, Andy here. So let's talk about the four quantum numbers. Quantum numbers. Now, what are quantum numbers? They basically describe the address of electrons in an atom. So as we know in our basic picture of an atom, we have electrons that are certain energy levels, discrete energy levels, away from the nucleus of the atom, and so they take different shapes, they're at different levels, and they fill different orbitals in certain orders. So it's important to know, how to describe their position and how to know when they change relative to each other. So there are four basic numbers that help us describe their position. The first one is the principal quantum number. Principal quantum number. This is also known, it's important to have this terminology in your head, as the shell number. And so the shell number is, the orbital that we were talking about earlier, kind of, in our picture of the atom where we have nucleus and then these different orbitals. The principal quantum number is that orbital, this. So 1 would be the first one, 2 would be the second one. So it's important as you go through all these numbers to kind of know what they're referring to in your different conceptions of the model. And so the number used to represent this is n, a little lowercase n. And so the principal quantum number, it's related to, let's get a cool color, it's related to the size and energy of the electron, and it designates the energy level. Energy level, like we said earlier with these orbitals. So a higher quantum number, higher n, right, equals a higher energy. Because as it gets farther away from the nucleus, there's more energy that it can give off. Okay. The second quantum number is the subshell number, denoted with an L. So what does the subshell number mean? It basically describes the shape and energy. But you don't really associate a subshell with energy, associate the principal quantum number with energy. So what are some of the different shapes? We have an S shape, which is kind of like a sphere, a P shape, which is like a dumbbell, then we have the D shape, which is some sort of combination of the two with the donut hole, and then we have the F shape, which I can't even describe. I don't know what it looks like. And so L, in this case, can be any number 0 onward, but the equation is n minus 1. So if you know your principal quantum number, you can figure out your possibilities for your subshell number. So if my principal quantum number is 2, then my subshell can be 1, right? And so what that means is each of these shapes is associated with one of those numbers. So S is associated with 1, S is associated with 0, P is 1, D is 2, and F is 3. You'll never get anything beyond that on the MCAT. And so let's say I'm in the second energy level. That means n equals 2, which means that L is 1, and so I'm going to have a P shape, kind of this dumbbell shape. Okay. Our third quantum number is the orbital number. The orbital number is noted by m sub L, and it basically describes the 3D orientation of the electrons. So what do we mean by that? Well, when we were describing these shapes earlier, for example, the dumbbell shape, we can imagine if we have a coordinate system drawn that this dumbbell can be in different directions. It can be in the y direction, it can be in the x direction, or it can be in the z direction, right? So there are different 3D orientations of these shapes, and the orbital number, m sub L, will specify which direction. And so the equation we can know for this is that m sub L, let's write it here, m sub L can equal 0 and plus or minus L. 0 or plus or minus L. And the integers of those. So you can, you can see how all these numbers, once you get one, you can get the next one and then get the other one to describe the position of the electron. The final quantum number is, I guess, the easiest, number 4. It's the spin number, denoted as ms, and it simply designates the inherent spin of the electron. And so m sub s can equal plus or minus 1/2. So it's either going to be plus 1/2 or minus 1/2. So let's write down all of our numbers again. We have the principal quantum number up here at the top, principal quantum number. Then we have the subshell number, L. And then we have the orbital number, m sub L. And then we have the spin number. Oh, I wrote that incorrectly. M sub L. And then we have the spin number, m sub s. And so these are your 4 quantum numbers that, remember, describe the electron address. And so what happens is you'll get an element, and they'll say, where could this electron be? Or where could it not be? And using these rules and these numbers and these little math calculations, you can determine which numbers are possible and which are impossible.